Hello all, today in this video I'm going to provide a demo video for logistic regression with spam detection. This data set I downloaded from Kaggle. You can just search it as email spam detection. You can just see the data set in Kaggle. So for this code previously we have done with some other machine learning algorithms, and in this demo we are going to work with logistic regression machine learning algorithm. By this, we can just make a comparison with the previous machine learning algorithms to just see which machine learning algorithm is going to provide better results with this particular data set. So first for that we are going to importing the libraries which we are needed, like pandas, uh, matplotlib as a plot, then train test split. Then we are going to display the accuracy score and also the ROC curve for this every machine learning algorithms. For that also we have imported the libraries we needed. Then we have just loaded our data set, which is emails.csv data set. This data set is having nearly 3001 columns, and in that 3002 columns, in that the first 3001 column we are going to use as the x variable, and the last column we will be using as the y variable. In that you can notice that we are getting the information of what data type this uh, every columns is. For that we are getting the info. We are getting that we are having 302 entries, and in that 3001 entries is integer, and only one is object. So this is the only variable which is an object type. Every others are integer type. So we are also checking whether is the data set is having any null values. It is not having any null values. So we are moving to the determination of x variable and y variable. As I said, in the x variable we are calling the first 3001 entries, and in the y variable the last entry, that is the prediction entry, is called as the y variable. Then we are splitting the x train, x test, y train and y test function by using the train test split function, and the variable with the help of variables x and y, and we are making the test size as 0.25, that is 25% will be taken for testing, and the remaining 75% will be taken for training. Initially, previously, we have worked with the random forest when we got an training accuracy of 100, and we also determined its ROC curve. Then we worked with the SVM. For SVM we got an training accuracy of 0.8092, and testing accuracy of 0.7710, and for this also we have determined an ROC curve with the FPR, that is false positive rate in the x-axis and true positive rate in the y-axis. Then we worked with the naive Bayes. In that we got the training accuracy of 0.9646, and for this also we have determined the ROC curve. Then we worked with the KNN, that is K nearest neighbors classifier. For that we got an training accuracy of 0.9064, and we for this also we have plotted the ROC curve with the FPR and TPR. Then we worked with the decision tree, for which we got an training accuracy of 100, and for this also we have plotted the ROC curve with the uh, FPR and TPR. Then in this code we have going to work with logistic regression, as I previously said. For that, initially you may know that for every algorithms only the libraries change and all others are equal only. So here you can see the only the library is changing, that is the logistic regression, and it's calling a function, that is a logistic regression of that we are determining within a variable LR. Then we are training it by using the variables train, x train and y train, and then we are determining the probability values and also the accuracy values for the training variables. Then we are making it to print confusion matrix variables, accuracy score, and ROC AOC curve. Like the same way we are going to make with the test results also, that is with the variables x test and y test. We are also going to print the values of confusion matrix, accuracy score, and ROC AOC curve for the trained results, test results also. So now you can see we are getting the values of trained results and test results. Confusion matrix, if you see, means obviously there will be a vast difference. Why? Because only 25% of the data we are using for testing, and the remaining 75% we are making for training. So training data will only show vast values when compared to testing values, since it is having nearly 75% of data. Then accuracy score for this logistic regression is 0.9832, and the accuracy score for this testing is 0.9590. Then we are also determining the plot, that is the uh, ROC curve plot with the TPR with the y-axis and FPR in the x-axis. Then we are making a comparison with all the algorithms we have made, like random forest, support vector mission, naive bayes, KNN, decision tree, logistic regression, etc. Then we are making a loop. Within the loop we are calling some models. These are the models. So we are making it to train, then test and all, and then we are going to display the values of accuracy, mean square error, and R2 square. Only here we are only printing the accuracy score. So the accuracy score of every values we have made, you can see it will be displayed over here. Then we are going to make a table, comparison plot table. Here you can notice with the table we have made some highlight points. What is the highlight points means, every model which is having some better accuracy will be shown in green color, and with the least accuracy will be shown with the red color. Here random forest is having the best accuracy, and say support vector is having the least accuracy. After random forest, there's logistic regression algorithm takes the place, and after that naive bayes, then comes the decision tree, then comes the KNN, and finally this is the support vector mission. So this is the comparison of every algorithms we have made so far. In the next code we will be working with some other machine learning algorithms with the same data set, and we will make a comparison of every machine learning algorithms. Thank you.